All right, so for section 4.4, we are on the third day of this. We have been solving exponential equations up to this point. Our shift now is to solve log equations. And I asked you to go back and review those notes from 4.2. What were some of the log properties that we had? Okay, log base b of b is 1. Okay, what was another one? Okay, and these are really the same idea, right? Because here our power is 1 and we're getting the power. Okay, so same idea. What was the third one? Okay, which says b to the 0 power is 1, so it doesn't matter what the base is. Okay, when you graphed a log equation, we had a vertical asymptote, and then our graph came up along that vertical asymptote and curved off this way. Remember those? Okay, so unless we have some kind of horizontal shift where we move everything left or right, our vertical asymptote was at 0. And that basically said our x's are getting really close to 0, but they're never going to get to 0. Okay? So what's going to happen today when we're solving log equations, we have to be really careful, because if you are trying to take the log of 0 or the log of a negative, you're going to run into problems. You're going to get error messages. Okay? So it is important today that we're checking those answers and making sure we're not creating a situation where we would be trying to take a log of 0 or negative. Okay? All right, so our day 3, we said logs are only defined for positive real numbers, and we are going to be watching for that situation where we have the log of a negative or 0. Okay? First couple here, we have a single log, and we're basically just going to use our definition of a log. How did we convert from log form to exponential form? Some of you learned it last year as snail shell. Yes? We talked about making a circle. We start with our base. Which one's our base in this expression? Okay. Which one's our power? The 2. Remember, the answer in a log is always your power. Okay, so this is your power. So we are saying 4 to that power has to give us that expression. So 4 to the second power has to equal x plus 3. So even though it was a log equation, we're going to think of it in its exponential form because we can solve that easily. Okay, 4 squared is, so we have 16 equaling x plus 3, which means x would have to be 13. Okay, so the solving part, once you've rewritten it in its exponential form, the solving part is easy. Okay, if we check that and we put a 13 back in here for x, we're stating that the log base 4 of 16, if we substitute a 13 in there, log base 4 of 16 is 2. Does that work? Okay. Second question, it's a little different. What's different about it? Okay, it's a natural log instead of a log base 4 like we had in the last one. But natural log just means base e. Okay, so it's still a log, it's just base e. What else is different about it? Yes, that number out front, you want to get rid of it, just like we did with exponential equations when we were solving them the last few days. Any of that extra stuff we wanted to get out of the way first. Okay, so our first step would be to divide the 3 out, which gives us the natural log of 2x equaling 4. All right, and now we can write it exponentially. Our base is e, so we're going to say e to the 4th power equals 2x. So how would we solve for x? All right. So e to the fourth divided by 2. And I'm going to have you leave that as your answer as opposed to giving me a decimal approximation. Okay, this is more exact. So just leave it like that. Okay, I'm going to pause the video. I want you guys to do questions 3, 4, and 5 with your groups. All right, so let's go back and check. We are solving question 3 here. We have 2 to the third power being x minus 4. All right, 2 cubed is 8. Adding the 4 over, did you get x being 12? And does it work? If we plug a 12 in there, 12 minus 4 is 8. We can take the log of 8, right? All right. Question 4, you divided a 4 over first. So you have the natural log of 3x being 2. Writing it exponentially, we would have e to the second equaling 3x. So x is, yes. Okay, and then question 5. Writing it exponentially, we have 2 to the third being x plus 20. When we solve that, we have x being negative 12. Is that okay? If we put the negative 12 in here for x, negative 12 plus 20 is 8. And that's okay, right? We can take the log of a positive number. Okay? So, questions on the first 5. Those are our more basic ones. How is question 6 different? There are 2 logs. Now, there's 2 logs on one side and there's no log on the other side, right? Could we condense this? Remember how we expanded and condensed log expressions? If we had a log plus a log, it condensed into what? Okay, so let's write this as the log base 2 of the product, x times x minus 7. And then it's similar to what we've just done. We can write it exponentially. Okay, do your snail shell or circle. The difference here is that we have this whole expression. So we have 2 to the third being x times x minus 7. And we're going to have to distribute that, get everything to one side. So it's a little more involved in the solving part of it. Distributing gives us x squared minus 7x. Over here we have an 8. And because it's quadratic, we have that x squared in there, we're going to get everything to one side so we can factor it. So how do we factor x squared minus 7x minus 8? Okay. So possible solutions, we would have x being an 8 or a negative 1. Okay, now here is where we really have to check. We're getting 2 answers. Do they both work? So if we put that 8 back in for our x, in the first one we're taking log base 2 of 8. We can do that. In the second part we're taking log base 2 of 1. 8 minus 7 would be 1. We can do that. So the 8 is going to work. Checking the negative 1. If we plug that back in, the very first term now says take log base 2 of negative 1. We can't do that. Okay, you can't take logs of 0 or negatives. So that would be considered an extraneous answer, and we would not include it in our final answer. Okay? All right, go ahead and condense number 7. All right, check. Did you write the log, common log of x times x minus 3 equals 1? Okay, what's our base? 10. So 10 to the first power has to give us x times x minus 3. Okay, so once again, we're going to distribute. It creates a quadratic expression over on this side. So let's go ahead and move the 10 over with this so that we can factor. All right, our factors would be, okay, x minus 5, x plus 2. So possible solutions, x could be 5 or negative 2. Do they both work? Does the 5 work? If we put a 5 in here for x and in here, we're taking the log of 5 or the log of 2. All right, that seems to be fine. If we put the negative 2 in, we're taking the log of negative 2. It's not going to work. So this would be my answer. This would be extraneous. Okay. Talk at your tables. How does question 8 condense? All right, so looking at question 8 on the left side, we have 2 logs that are separated with what symbol? Subtraction. We have a log minus a log, and subtraction in logs condenses back into division. When we condense, we have 1 log in front, and then we have our division, our fraction piece. So we're going to have x plus 2 being divided by 4x plus 3. We okay with that side? Okay. And on your papers, go ahead and change, you have minus 2, make that a plus 2. That was a typo here. Okay, on the right-hand side, we have the natural log of 1 over x. So this one is a little different because in all of the other ones, we just had a plain number on the right-hand side. So we could do our circle and, all right, we don't want to do that here. We don't want to try to take the e to the log base e of 1 over x. That makes it more complicated than it needs to be. It's like our exponential ones. When we had things like 4 to the 2x equals 4 to the 8th. If the bases were the same, like they were both 4s here, we could set the powers equal. Remember doing that? Okay. Well, we have the same kind of log on both sides. So if I'm taking the natural log of something and it equals the natural log of something else, those expressions are going to have to be equal. So we really can ignore the log piece here. Our x plus 2 divided by 4x plus 3 really has to balance with a 1 over x. Now, this requires some solving. How do we solve a proportion? Proportion, fraction equal to a fraction. Cross multiply. Okay, so cross multiplying. We have x times the x plus 2 equaling 1 times the 4x plus 3. Okay, so just cross multiplying. Go ahead and distribute. Have we created a quadratic equation? Do we have an x squared in there? Okay, so then we want to get everything to one side so we can factor it. Subtracting 4x is going to leave me a negative 2x, and then subtracting 3, and we factor it. Okay, so possible solutions, x could be 3 or negative 1. Now go back and look at the original equation. It has to be the original one, not the one that we've condensed. If we put a 3 in, are we okay? Putting a 3 in for x? Do we end up with any negatives or zeros? No, so 3 is going to work. Okay, putting a negative 1 in, negative 1 plus 2 is fine. 4 times negative 1 plus 3 comes out negative, doesn't it? So the negative 1 is not going to work. Just the x equaling 3. Okay, I'm going to pause the video. I want you guys to try question 9 on your own. So let's check question 9 here. Maybe. All right. Condensing on the right-hand side, you should have the natural log of 7x minus 23 over x plus 1. All right, and since we have natural log on both sides, we can eliminate the natural log piece and have x minus 3 equaling 7x minus 23 divided by x plus 1. Okay, picture a 1 under there so you can cross multiply correctly. We have x minus 3 times x plus 1. Foiling that out, we have x squared minus 2x minus 3. And adding everything to one side, we get negative 9x and a positive 20. So it factors into, okay, so solutions could be a 5 or a 4. Okay, does the 5 work? Yes, it's not creating any zeros or negatives that we're trying to take logs of. And does the 4 work? Okay, so this is an example where we got 2 solutions and both work. Okay, that can happen. Questions? Okay, so you guys are going to work through 49 to 91, just the odds. I've given you odds so you can check your answers, but obviously there's some work involved. I expect to see that work shown.